Good evening, everyone. This is BremSter, and I'm coming to you with yet another puzzle. This is I'm pretty happy to get this one. So those of you who follow Cracking the Cryptic will be aware that the next Patreon bonus that Cracking the Cryptic are doing is from what's been called the Paint by Numbers Institute, and that is two setters, Panthera and the Asylum. And it's going to be quite a large pack of puzzles which are all based around colouring and creating shading in grids and other forms of colouring puzzles possibly. Panthera is someone I have chatted to a lot. Panthera is someone I'd like to call a friend, or I do call a friend. And after creating this apparently huge puzzle pack, which will be released to Cracking the Cryptic Patreons, and also a preview pack, which is available for free on the Cracking the Cryptic Patreon. This is what it looks like, which is the bonus puzzles pack as an introduction. Panthera then created two puzzles for me so I could release to my channel an explanation of how Japanese sums work. So these are two puzzles specifically created for me so I could show you how this works. I have done a Japanese Sums Sudoku puzzle by Panthera before on my channel called, the puzzle was called Down Under, and I will try and remember to throw a link to that other video. But if you don't want to watch this one and that one, you can just watch this one. This is a puzzle created by Panthera. I've got a second puzzle which I'll show later, which is apparently only going to be a couple of minutes. But this one is going to be a full length, which is the Japanese Sum Sudoku type, which is what Panthera is mostly known for. So she's just churning out puzzles, and I did want to do this so I could get this video out before the Cracking the Cryptic Patreon bonus comes out. If you're not a Cracking the Cryptic Patreon member, I highly recommend going over and joining it, because for only $2 you will get like all of these puzzles every month. And if you pack it for, I think it's $3 a month, you'll then get all videos and other bonuses as well. It's well worth doing if you're into puzzles. So this puzzle and how do Japanese Sums Sudoku work. So this puzzle is called Duck. I imagine we're going to find out why. And the way Japanese Sum Sudoku work is it uses normal Sudoku rules, which is in every box, in every row, and in every column. The digits 1 to 9 must be placed without repetition. But we're going to have to shade this grid. And the way we're going to shade the grid is in each row and column, there will be a shaded region, and the shaded regions will be determined by, the totals of the shaded regions will be determined by these numbers at the top and on the side of the grid. So, for example, in this row, there will be a shaded region with a total sum of 2 and a shaded region with the total sum of 3. In this, so there'll be two shaded regions, and the two shaded regions must be separated by unshaded regions. In this row, there must be a single shaded region with a total of 29. In this row, there'll be two shaded regions, one totaling 14, one totaling 3. And it'll be the same going down. There'll be a single shaded region totaling 5. There'll be two shaded regions totaling 10 and 13. And from this, we'll be able to figure out both the shading and, using the totals that need to be in those shades, what the numbers in the grid will be. That is how Japanese Sum Sudoku works. I'm not very good at these puzzles, but the goal is now to figure it out. Because there'll be math on this, I am going to have my calculator open on the other screen. So let's see how we go. So what I normally do when doing these is I look for big digits. So there's a 38 here. So if I look at my calculator and figure out how many digits do I need for a 38 needs to be at least 6 cells. So if I was to start here and go across, these cells would be included. If I was to start here and go back, these 3 cells would be included. So I know that those 3 cells are definitely shaded. 23 could be in as little as 3, so I can't do the same there. 36, I think, is the same. Yes, it is. So those 3 must be shaded. But there's more pressure on this row because 36 must be 3, but I need to have a 6 here. So the minimum the 6 can be is taking those two cells. Now, it could possibly take those two and then this be unshaded and then all 6 of these are shaded, but it must take a minimum of those. So it can start here and go 1, 2, 3, 4, 5, 6, or it can start here and go 6. So these two, whichever way we start, whether we start here or here, these two will also be shaded. And it could be there, and then this could be unshaded, this could be shaded, and this could be unshaded, or this could be shaded, this could be unshaded, this could be shaded, or yeah, there's options here. 29 must be at least 4, which doesn't help us because I could do 4 to there, 4 to there, there's no crossover. 2 and 3, they could be anywhere. This is a 37, which means those must all be included, but there's a 4 first, so it's a bit like this one. So if this is a 4 and then unshaded, 37 still needs to be at least 6. So if this goes 1, 2, 3, 4, 5, 6 or up, then these must all be shaded. That's going to affect the horizontal again, but we'll look at that in a minute. 20 and 22. Okay, I think I can do something here because I can't do 20 in less than... I can't do 20 in 2 because 8 and 9 is 17. So I couldn't do those two shaded, this unshaded, and this being the 20. So these both need to be part of the 22, which means that becomes shaded. But then I've got lots of options, although I do need to have 3 in the 20 as well. So this is the 22, though it could go down further or even up further. The 22 could come to here, this could be unshaded, and this could be the 20, or this could be the 20. But either way, those two cells need to be part of the 20, because if they're not, so even if it stops here and I start here, this becomes part of the 20. And if it goes further and stops here, this is the 20 for those 3. So these two will always be part of the 20. Oh, and this is the reverse. I need a single region in this column. So these two cells, which must be shaded, must be joined. And 11 cannot be 5. So if the minimum that a 5 cells can be is 1, 2, 3, 4, 5, which sums to 15. So this can only grow by 1 more in either direction. So if it goes down, all of those will be unshaded. If it goes up, then those will be unshaded. Either way, all of those will be unshaded. 13 and 12, I could have those shaded and it's separated there. I could have those connected, and then, yeah, that doesn't get me anywhere. These are also fairly open. 26. 26, you can do 26 in 4, so I've got the same problems I had somewhere over here. So that's not helping me. This 29, how many do you need for 29? Because this is part of it. This is shaded, this is not shaded, and it must be a single region. So all of these are unshaded. How many do I need for 29? I need 4. So these are all shaded. This is now the 37, that expands the 37 region. So this must be unshaded for this to be shaded, and I've got my first digit. That must be a 4. So Another trick, so what I've been focusing on at the moment is just the shading based on the minimum and maximum sizes that you can put in. And that is one of the tricks you do to get started with a Japanese Sum Sudoku. Now I'm going to start looking at one of the other tricks. So one of the tricks you just saw me use there is because we were able to get a single cell region that had to sum to a 4, we could just put the 4 in. But one of the other tricks you want to look at is what's called the outies. At least that's what they're called on Cracking the Cryptic, which is we know that the shaded cells in this column have to sum, or an entire, sorry, the shaded cells in this column must sum to 37 plus 4, which is 41. Oh, that does help. Because an entire column, and the same is true for an entire row, will contain all of the digits from 1 to 9 because normal Sudoku rules apply. If you add the digits from 1 to 9, you get 45. And we've determined that all of the shaded cells in this column sum to 41. So the unshaded cells must sum to 4. 45 minus 41. Now, if this was to grow by another cell, you could say that that would work. But the number that is not the digit that isn't shaded would have to be a 4 because it would need to be 45 minus 41. And we would need to put a 4 here, which does not work. So we need another unshaded cell so we can have 2 digits summing to 4. And the only way you can do that is with 1 and 3. And it can't be a 3 here because in this row, we need to put a shaded cell, which is, so we need to have a region, pardon me, we need to have a shaded area, which is worth a value of 2, and a shaded area, which is a value of 3. So if we were to do once we've done a shaded area of 2, there's only one way to do that, which is just a 2. You cannot use 2 1s. The only ways to make a shaded area of 3 is a single digit 3 or a 1, 2. But we've already used the 2 to make the 2. So we know that in here there will be 2 single shaded areas. One is a 2, one is a 3. This is an unshaded cell, but we know that the 3 must go into a shaded cell. So this has to be a 1 and this has to be a 3. And this sums to 8. And 45 minus 8 is 37, which is what we need to put in there. So this column is now complete. We do not know whether that's a 2 or a 3. So if it's the 3, the 2 will have to go in there. If it's a 2, the 3 will go somewhere over there. We've got the 4 for the top row. These are all unshaded. That's going to have huge impacts up here. So in here, the first shaded region needs to be a 13. You can't put a 13 into a single cell. That becomes unshaded. You can't put 16 into a single cell. That becomes unshaded. You can't put 26 into a single cell. But single cell. She sells seashells by the seashore. You can put 2 into a single cell, though. No. This is another cool trick. So we know in this row, we must have a 2 and then a 3 because it may not be stated in the rules, but these have to happen in order. There is a 2 and then there is a 3. But if we were to do here, there is a 2 and then there is a 13. If we make this 2, we have to put a 3 after it, and there's no room. So this cannot be a 2, because then we would have a 2 here, and we could not, once we put the 3 in, these are in the wrong order. This has to be unshaded, which means this is the 3, and we need to put a 2 in there. 29 in 4. How many ways are there doing that? 1. This is 5, 7, 8, 9. And this is me looking at my calculator where I've got all of the possible ways. It's actually a killer cage calculator, but the math is the same. In here, 14 needs to be at least 2 cells. So the 3 will need to be over here, because if I put 2 cells, then it turns into 3 and I can't, yeah, the 3 is over here somewhere. But I don't know whether this is 2, 3, maybe even 4 cells. The same is true here. This is part of the 14, but I don't know. It could go that way. It could just be those two. I do not know. Have I learned anything about this? This could be 7 grey and then 15, I think. Wait. This column. This column. So I'm going to start with just the base shading. This cell must be shaded with only after a single thing summing to 5, and you can only make 5 with 1 or 2 digits. So the 5 is either just here or in those cells. So all of these become unshaded. Now, once I've made these, the only way to do this is with a single 5 or with 1 4 or 2 3. And I cannot put 1, 2, 3 or 4 into this cell. This becomes a 5. These become unshaded, and I take 5 out of all of those. This is unshaded. This has to be the 2 and becomes shaded. I need to put a 10 in here. This can't be a 9 anymore because this needs to be part of a 10. It's either 2 8 or 2 7 1. It could be 2 7 1. If it's 2 8, that's unshaded, and then it could grow. If it's 2 7 1, that's yeah. So I don't know enough to say what happens after that yet. So this, now 36, I think I determined it needed to be at least 6. 1, 2, 3, 4, 5, 6. Yes, that's true. The maximum you can put in 5 cells is 35 with 5, 6, 7, 8, and 9. So this is my 6. I still need to get another digit. So that's unshaded. That is shaded. Because always remember, the regions need to be separate. That gives me a 6 here. 36 plus 6 is 42. 45 minus 42 is 3. So I need to make those sum to 3. They have to be 1 and 2. I need to put a 2 in there, because I need to have a 2 and then a 13. Because a 13 must be at least 2 cells. So, but there needs to be a 2 in a shaded cell in this column. So that becomes the 1, that becomes the 2. Now the 13 will be down here and the 2 will be up here, because 13 in 2, there's no room to do a grey and then a 2 down here as well. That's way too many cells. So the 2 will be up here somewhere, and then I make 13 down there somewhere. What about this, 16 and 13? I can't, this is part of the 16. If this was to grow down, there's no room for the 13. So this has to go up. Then this has to be grey and this has to be 2 cells, because I need to have enough room for there to be 2 cells for the 13 and then for the 16 up here. The 16 could still be 3 cells, but I do know that that's the 13. Can I do the same with the 13 and the 12? So the 13 can't go down and the 12 can't go. If the 12 can't go down, these have to be separate. Because I'm trying to explain this clearly, and I hope I am. If these connect, then, so if this becomes yellow, then I need to put grey on either side, and I can't put the 13 in here. So that doesn't work. So this needs to separate these 2 regions. The 12 needs to be at least 2 cells, and the 13 needs to be at least 2 cells, but I don't know if they go further. This is an 11. Yeah, I'm not sure about that. 20 and 22. 26. How much does 26 have to be? I think I've asked this question before in relation to another area. 26 needs to be at least 4 cells. So if I start here and go 1, 2, 3, 4, that is shaded and clearly from the other direction. So this is a shaded cell. Oh, wait a minute. This is 7 and then 15. So 15 needs to be at least 2 digits, but this needs to be 7, which cannot possibly be more than 3, and is 1, 2, 4. That is something you learn as you do killer. So that is that row done. This is 10 and 13. There is no way I can do 10 in 5 cells. That's not possible. So these have to be different, because the minimum you can do in 5 cells is 15. 1, 2, 3, 4, and 5. And this has to be high. So these are different regions or different shaded areas, which covers my 2 shaded areas. These become unshaded. I need to separate these, and this needs to be at least 2 in size. That shaded, that is unshaded. This needs to be a 10, which makes this an 8 and takes 8 out of both of those. This needs to be a 13. The options for 13 are 4, 9, 5, 8, and 6, 7. I can do 4, 9, or I can do 6, 7. This is a 14, so that has to grow. I've then got a 3 in here somewhere. This is a 14 and a 23. 23 has to be at least 3. So I could do 1, 2, 3, or 1, 2, 3. 14 could grow. Yeah, that's still open. 23 has to be at least 3, so this could grow in either direction. I need to put a 2 in one of those 2 cells by Sudoku. This 38 is now not fixed, but we do know it needs to be 6. So it goes to there. It might also go to there. Do we remember the name of the puzzle? Because I'm kind of seeing why it's called that. But we're never going to make an assumption based on shape. So this is going to come up to 20, but hang on, these need to be separated, the 20 and the 22. This has to be unshaded. So I need 17 in here. There's only one way to make 17, and that's with 8 and 9. So that has to be a 9, that has to be an 8, that has to be a 7. This has to be 14 with 2 digits because that's unshaded. This is 8, I need another 6. It takes 6 out of there. So 6 and 7, this becomes a 4-9 pair. We're making some progress here. This is a good puzzle. Now, do I know more about this 11 yet? I probably should, but I don't. What am I missing? 23 again. Oh, it could be 3, as I said. What about the 22? What about the 22? That's a low digit. 22 in 3 is 5, 8, 9 or 6, 7, 9. So I can't make it 3. This needs to grow by 1 because 5, 8, 9, 6, 7, 9, if this was only 3, this digit would need to be higher. So this needs to grow by a digit. I need to connect these because row 9 has only a single shaded section. So this 23 is at least 4 long. I've now got the 22 in here. Now, what I don't know what the 22 is made out of, but I do know what it's excluding. More than that, I know that the entire shaded section sums to 42. So now I know there are 2 unshaded cells, and I possibly should have looked at this earlier, that have to sum to 3. So that's another 1, 2, which means this is a 4. These are not 4. Oh, there's a 1 looking down here. This is a 2. This is a 1. This is not a 2. That's my 7. But I can possibly look at this 22 now. So 22 in 4. Actually, I know what that is. I don't need to look at it because there's only 3 possible things left. So I've got 1, 2, 3, 4, 5, 6, and 7. So if I add 5, 6, and 7, I get 18 plus 4 is 22, which is what I need. So I've got that sum. I'm not sure what I'm supposed to look at next. Still need to put a 2 in here, but I don't know where. These 3 cells are limited, so let's put them in. 3, 6, and 9. Well, that can't be 9 because there's a pointing pair of 9s here. That can't be 3. This is, okay, that's not that helpful. 1 must be in there. 3 must be in there. 7 must be in there. Because 1, 3, and 7 are all looking at those cells. So this has to be, actually I could have done it this way. 1, 2, 3, 4, 5, 6, 7, 8, and 5, 8, 9, and 9 can't be there. That's a 5, 8 pair. That becomes a 9. And that gets me my 1, 3, 7. That 5, 8 is not resolved, and that 9 doesn't do much. Don't know. This is a 14, which is 9, 5. If I have an 8 in here, I'd need to put a 6 here. And I can't do it. This is 5, this is 9. That makes that 4 and that 8. So that 14 resolved all of this. These puzzles are so clever. I don't know how Panthera manages to just make them so quickly. Does not look up. She really is clever. So I need to do 23. I wonder if I can reduce the options by knowing what's not available in the row. So, but I don't know how long it is. Hang on, 11 can't go to 5 long. The maximum 11 can be is 4 long. So that must be grey. 11 in 4 long only has one option. 1, 2, 3, and 5. That can't be 2. That can't be 3. Nine has to go in one of those two. Now this, I'm going to put in these. So what are we missing? 1, 2, 3, 5, 7, and 9. So this 23, we know it can't be 3 cells anymore because 23 in 3 cells is 6, 8, and 9, and I can't put a 9 in it. This must be 4 cells long. So it's 23 in 4 cells long. So let's look at the options for that. Again, I'm just punching them into my calculator. Now, I can't use a 5 or a 9 So I'm going to remove anything that uses a 5 or a 9 from my list. So that leaves me with only 3 options. No, it only leaves me with 1 option. 2, 6, 7, 8. This must be 2, 6, 7, 8. I can't put 6 in there, so this becomes a 6. This is 2, 7, 8. We knew that 2 had to be in one of those two, so that becomes the 2. This is not a 2. I can take 2 out of there. I can take 7 out of there. This becomes unshaded because I've now got my 2 for the column. That's insane. This becomes a 1. This becomes a 2. This is not a 1. It's also not a 7. That's a 3, and I can take 3 out of there. That takes 3 out of there and puts 3 into there because of the 6-9 pair. So clever. This now, 1, 2, 3, is a 4. Oh, this has to be close. So most of the, or a lot of these clues are now done. This needs to be 12. So the way you can do 12 in 2, there's a few of them. 3, 9, which would be 3 and then 9. 4, 8, which I can't do because there's a 4 in the box. Or 6, 7. No, 5, 7. 5, 7. Do the math correctly. 5, 7. And if it was 5, 7, it could be in either order. None of those are an 8. Where can I put 8 in this box? 8 must go there. This is the only place for a 9. And now in order to get to the 12, 9 plus 3 is 12. That takes 3 out of there. I've got a 2, 5 pair. I can take 5 out of there. This is a 6, 7. This becomes a 5. And this is all just... So what I'm trying to show you here, 3, 5, that becomes a 9, that becomes a 7. What I'm trying to show you with these Japanese sums puzzles is there's a lot of different things that you need, Japanese Sum Sudoku puzzles, is there's a lot of different things that you need to look at. You need to, and I wish I was better at them to demonstrate it better, but you need to look for the values and the ranges that those values can be in order to do the shading, a bit like sandwich Sudoku. And then once you've done that, you then need to sort of figure out what pressures you've got from the digits. This is a very good puzzle for me to try and figure this out. So we need 13. 7 plus 6 is 13. This becomes unshaded. We need 16 here. We've got 9. If we add 7, we've already hit the value. We could, if we put 8, we would blow the 16 total. So this becomes unshaded. We need 1 more. We've got the 14 here, but we need to put a 3 in. So that has to become 3 and become shaded in order for this row to be complete. There's a 7 looking over here. This becomes an 8. These aren't done yet. There's possibly Sudoku we're missing. So this needs 4 and 5. So what have we got here? Excuse me 1 second. What have we got here? We've got 3, 8, and 6. So this is totaling 11, 17. So we need another 9. So we could do that with a single 9, or we could do it with, can't do 1, 8. Could do 7, 2, can't do 3, 6, could do 4, 5. So there's multiple ways of doing that. Or 9 in 3 would be, can't do 1, 2, 6, can't do 1, 3, 5, can't do 2, 3, 4. So this cell is unshaded. So now we've got 23 across the bottom here. 23 in 4 has lots of options. 23 in 5 has lots of options. I don't know how to narrow that down. So what can I do with Sudoku? 8 and 8. That puts 8 in one of those two. These two cells are known to be 2. In fact, 2 must be there. So this must be 1, 2, 3, 9. But this isn't helping me resolve any of this. This is a 15. And it can't have an 8 in it. This is a 9, 6, and we know the order. Now I know more about this. So I needed another 9 in here. This becomes unshaded. So now this is the 38. So these digits must sum to 7. So they have to be, these are unshaded, and these are 3 digits in the row that must sum to 7. So as before, they must sum to 1, 2, and 4. That can't be an 8. That has to be the 8. We now know 8 must be in one of those two because of the 8s looking into the box. Oh, can't put the 2 there because of that 2. So this becomes the 2. This is a 1, 4. That 4 is making that 1 and that 4. That 1 is looking up, making that 7 and that 1. These are a known 3 digits, 5, 6, and 7. Can't put 6 up there, so that 6 goes down there. That 7 is making that 5 and that 7. That 6 makes that 7 and that 6. That 2 makes that 5 and that 2. "13 with a 6. If this was 8 and 6, that would be 14, but these shaded cells need to be 13. This has to be the 8. This is not the 8. So now I know the total of this and whatever this needs to be. So we've got 15, 20, 23, 31. This needs to be a 7. 7 plus 6 is 13, which is what I need. This cell becomes unshaded. Now that I know that this is unshaded, this is 9 plus 9 is 18. In order to get to 23, I need another 5. And that is now completed. And I have completed all of the shaded areas. And we should just be down to Sudoku now. I need to put a 1 in this box. I can't put it there because of that one. I can't put it 1 because of that one. That becomes a 1. These are a 3, 4 pair. That 4 is resolving it for us. 1, 2, 3, 4, 5, and 7. There's a 5, 7 there, so that becomes a 4. 1, 2, 3, 8, and 9. There is an 8, 9 there, so that becomes a 3. Let's hope that continues. 1, 2, and 6. There's a 1, 2 there, so that becomes a 6. There is a 2 there, so that becomes a 1, and that becomes a 2. That 6 looks back and makes that a 9, and that a 6. This row needs a 1, which must go there, and a 6. This 9 looks back, making that an 8, and that a 9. Let's look at this column. 1, 2, 3, 4, and 5. That 4 is telling us the order, the 4 that was there. The 5 now makes that 7 and that 5. And in this box, I need 1, 2, 3, 4, 5. I need 7 and 8. That 7 is telling us the order, 7, and I put in the 8, and that looks good. And yes, let's make all of the grey cells blue, and we have a duck on the water. So that's why the puzzle was called Duck. In fact, let's give it its grey wing back. I didn't do that right. So Panthera, let's give it a black eye. I didn't mean that by let's wound the duck, but so that is hopefully an example of how you do a Japanese sums Sudoku. For those of you who are curious, I should have said at the beginning, I may have said at the beginning, links to these puzzles, of course, are below the video for those of you who want to try it. So now I'm going to show you another puzzle, which Panthera has assured me will only take a couple of minutes, which is one of the variants that I believe appears. This is a puzzle that she has created. I'm not going to change the rules on the side because, but I will explain the difference, but it is only a minor one. So this puzzle, which is called Impostor Letters BremSter. So she has absolutely made this for me. This uses exactly the same rule set. There's only two differences. One is one of the shaded cells has been provided. And the second one is the clues outside the grid are either giving you the sum of the shaded cells in the row or column or the unshaded cells. So the way it's been phrased in the rules is some column row clues were changed to represent the unshaded cells instead of the shaded ones. So we do not know whether the clues are representing unshaded cells or shaded cells. And I believe that's why we've been given a shaded cell in this puzzle in order to be able to resolve it. So now let's try and solve it. Oh, okay. So the thing to remember, this is a 5 by 5. So all of the digits only sum to 15. But we've got 3 clues in each of the columns, which must sum to the which must be separated. So we know that this will be a shaded cell, this will be a shaded cell, and these will be unshaded, and this must be a 1, this must be a 5, and this must be a 3, so these will be 2 and 4. These 3 cells, which will be either shaded or unshaded, so they'll be, let's use green and orange, yellow and orange. Hopefully that's visible. I'll try and pick a different color. Let's use blue. So we don't know if these are shaded or unshaded, but this will have 3, 2, and 1, so these will be 4 and 5. These, we don't know if they're going to be shaded or unshaded. I'm just using the same for the moment. 2, 4, and 5, which means these will be 1 and 3. These, we do not know if they're going to be shaded or unshaded, but we do know 4, 1, and 2, which means these will be 3 and 5. And all of these are going to either be shaded or unshaded, but we don't know what. Remember, green is shaded and grey is unshaded. The others, from the columns, we know this, but we don't know anything else. Now, we do know that that's going to be a 5 to complete the row. That's going to be a 3 to complete the row. That's going to be a 4, so these are a 1-2 pair. 13. So now I'm looking at the rows. 13. 5, 4, 1, and 3 is 13. So these are the shaded cells. So I know that all of those are shaded. And because all of those are shaded, this 0 clue means that all of those are shaded. All of those are shaded. And all of those become unshaded. All of those become shaded, and those become unshaded, and that's simply from the 13 clue, because the 13 clue needed to give us, we needed to get the 13, but this one needs to be, these 3 now need to be unshaded, and these ones need to be shaded, and these are unshaded, sorry. And that's the pattern to give us the 13. So we now need to figure out what this is. So this needs to be 12. Outside the 12, we need 3 with 2 unshaded cells. So it needs to be 2 and 1. That makes that 4, that 5, and that 3. That becomes a 3. That becomes a 1. That becomes a 5. That becomes a 4, and that becomes a 2, and that completes the grid. And we've got the 1 and 3 shaded, and we've got 10 shaded. That's 11 shaded, and that's 12 unshaded. So that matches. Oh, it's a B, hence being called Impostor Letters BremSter. It's B for BremSter. Thanks, Panthera. Now, one of the things I meant to do on the previous puzzle. So, sorry, before I do that. So that's how the imposter or what puzzles work is you do not know whether the clues are going to represent shaded or unshaded cells, and you'll have to figure that out. One of the things I did mean to do on this puzzle was go back and show you that all of the sums hopefully worked. So the 4, that's a 4, 2, 3. We've got a 2 and a 3. 29, 13 plus 7 is 20, plus 9 is 29. 14, 8 plus 6 is 14. That's a 3. 14, 9 and 5 is 13. 6 and 7 is 13. Plus 2 is 15. Plus 8 is 23. 36. Now, I know that this is a 6, and the way I'm going to calculate the 36 is rather than add up all those numbers, I've got a 6, a 1 and a 2, which is 9. If I subtract 9 from 45, I get 36. 1, 2 and 4 is 7. 6 and 9 is 15. Remember, these are unshaded. I just coloured them to complete the duck. 38, again, we've got 2, 1 and 4 outside the shaded region. 45 minus 7 is 38. This one we could do either way. 7 plus 2 is 9, plus 8 is 18, plus 5 is 23. Going down, this is a 5, 2 and 8 is 10, 9 and 4 is 13, that's the 4, 4, 1 and 3 is 8, 45 minus 8 is 37, 17 plus 3 is 20, 5, 4 is 9, plus 6 is 15, plus 7 is 22, 4, 9, 11, 6 and 7 is 13, 3 and 9 is 12, 7 and 9 is 16, 8 and 5 is 13, 2 on its own is 2, 6 and 7 is 13, 3 and 8 is 11, plus 6 is 17, plus 9 is 26. So all of the digits sum up. Thank you, Panthera, for sending through those two puzzles. I really hope that everyone gets the picture puzzles pack, or whatever it's called when the official Patreon pack is released. I hope everyone jumps onto the Cracking the Cryptic Patreon page and downloads the bonus puzzles that have been released for free and gives those a shot. I hope that people who haven't seen Japanese Sum Sudoku before find this video helpful for understanding how they work, and possibly helping them as a guide for the plethora of puzzles that the Paint by Numbers Institute, which is Panthera and the Asylum, are coming up with in about a week. Good luck, everyone. I hope you enjoy your puzzles, and thank you very much for watching.